Hi everyone, in this video we'll be demonstrating our practical 5 for EEE3096 and my name is Luando. I'm with my colleague
and Sizamkele Ngwemla.
Right, so we'll start off with how we've decided to divide the work. First, our main goal was such that our circuit design would give us the output readings of the temperature in degrees Celsius and at the same time being a reliable circuit. So with that, we've decided to include a secondary circuit that uses an LDR. So if our output reading do change as expected when we're varying the light intensity about the LDR, and then that would mean that our circuit is reliable and we can be comfortable to use the MCP9700, which is our low power linear active thermistor. So next we'll be looking at the design and how we've went about the connection of our circuit design.
In this practical, we are going to measure and sample temperature using the MCP9700 thermistor and the MCP3008 analog to digital converter. The data will be sampled on a 10-second interval. A light-dependent resistor will be used when determining the light intensity. The circuit shown on screen consists of two sections: the actual circuit with a thermistor, which is used to measure and sample the temperature, and the secondary circuit with a light-dependent resistor is used to determine the light intensity. For the first circuit, the analog to digital converter is connected to the Raspberry Pi with the VDD pin of the ADC connected to 3.3 volts, the reference pin of the ADC connected to 3.3 volts, and the clock pin of the ADC connected to the synchronous clock pin of the Raspberry Pi, the output data pin of the ADC connected to the master in slave out pin of the Pi, and the input data pin of the ADC connected to the master out slave in pin of the Pi. The thermistor is connected to the ADC with the VDD pin connected to 3.3 volts of the Pi, the output voltage pin connected to channel O of the ADC, and ground is grounded. A push button is then connected to pin 16 of the Raspberry Pi and to ground. The analog data measured by the thermistor is sent to the ADC via the channel O pin, where it is converted to digital data and sent out of the output data pin of the ADC to the Raspberry Pi and displayed on the table or the light dependent resistor. The code used in this practical is divided into 4 main blocks. The initialization block, where all the necessary dependencies are imported from the Python libraries. This block includes the button press setup, the board mode setup, the GPIO setup, creating the SPI bus, creating the chip selector, creating the MCP object, and also creating a list of all the time delay factors. The output display block, where the temperature data samples are displayed in the correct format. The thread block for the push button, and the main block, which is called to run the program.
So we have over here our thermistor and also our chip ADC. You'll also realize that we're using these terms interchangeably. It's an MCP3008 or just simply an ADC. And we also have our push button. So we can say this is our primary circuit or our actual circuit, and then we have on this other side our secondary circuit that has the LDR with a resistor. So firstly, we'd like to work with our secondary circuit first, that is being connected to the actual circuit, and then from there we can use a channel NOT, which is our pin 1 of the ADC. We can use it to take readings from our thermistor. Right, so let's start off with using the LDR. Right, so if the LDR does work as expected, then we can safely go to our ADC our MCP 9700, and then be comfortable enough with believing that the results that we do get from the temperature reading is actually the actual temperature inside the building. So now what we will do, I'll go switch off the lights in the room, and I'll use the flash of this mobile phone, and I'm going to try to move the flash about the LDR, and then if the flash moves away from the LDR, then we expect a different reading when the flash is closer to the LDR. Okay, so as you can see, I have already SSH'd into PuTTY. I'll just simply go and say python3 sensor.py. Everything is connected correctly, and then now we are going to see the changes in the light intensity variation. Right, so and also remember that the push button at first is not being clicked, but we do have a thread that if you do click the push button, now the time delay that gives us the output changes will drop from 10 seconds to 5 seconds to a second, and then if we click again, it will delay for 10 seconds. Now, as you can see, the results are being given in intervals of 10 seconds. Now we'll click the button. The button is clicked, and then we're getting the readings in intervals of 5 seconds. So we actually, let's shine a flash. You see now. The reading has increased from negative values of the degrees Celsius. As you can see, the output is in terms of degrees Celsius, and that's nothing very necessary. Within our code, we just wanted to see if does it change with a change in the light intensity. Because what we're interested in is to see if our whole circuit does operate as expected. We don't have to really, reference our output in terms of lumen and stuff. So now we'll try to make our readings to be more faster by clicking at the time interval to be 1 second. So now, as you can see, the flash was off, and then we're getting negative values, and then flash is on top of the LDR, we're getting high values, and then moving the flash a little bit back, the values drop, closer, the values increase, and then back, they are dropping down to negatives, and then closer again, they're increasing.
In conclusion, figure 2 shows the results of the LDR when the lights were turned off and when the flashlight was turned on. When the lights were turned off, the temperature values measured by the LDR were negative, and when the flashlight was turned on, the temperature values became positive. Since the temperature values measured by the LDR changed from positive to negative, it can be concluded that the thermistor setup was correctly implemented. Figure 3 shows the results of the thermistor in operation. As the rate of sampling was toggled between 10 seconds, 5 seconds, and 1 second, the results were varying between 27.66 and 28.3 degrees Celsius. Since there was a small difference between the measured temperature values, it was concluded that the temperature reading algorithm was correctly implemented. That is, the time delay worked well with the use of a push button.
And until next time, thank you for watching.